Lesson 1.7, linear inequalities and systems of linear inequalities. Okay, so we got to remember how to graph a linear inequality. You're basically graphing a line, and you're either having a boundary line or you're having a solid line. So we've got a couple of steps. One, you're going to solve for y. We're going to get it into y equals mx plus b. Watch out, if you divide by a negative, you got to flip the sign. 2, dotted or solid. You can tell before you start. You know this one's going to be dotted. It's like an open circle because it's not or equal to. If it was or equal to, then it's solid. 3, you're going to shade above or shade below. And you can determine that with the y is greater than or less than. You can also pick a point on either side and check to see if it satisfies the original equation. I like to use 0, 0 when I can. So if I'm solving this for y, I'll move the x over. Negative 2y is less than negative x plus 4. Divide by negative 2, divide by negative 2, divide by negative 2. Be very careful. I got to switch that sucker to a greater than. And then it's 1/2 x minus 2. Next, plot the y-intercept of negative 2. Apply the slope of positive 1/2. I know positive goes like this. Up 1, right 2. Up 1, right 2. Up 1, right 2. 2. Down 1, left 2. Down 1, left 2. I already know it's dotted. Made note of that right away. Dun, 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 dun. That means it's all the points up to that, but not including that line. This is a boundary line. And then we have to determine whether or not we shade above or shade below. I like to just focus on y is greater than. This is the y-axis, and they get bigger up here, and they get smaller down here. So I'm going to make the assumption that this is my solution set. Now, the origin is in my solution set. So when I go up to the original equation, 0 minus 0, I ask myself, is 0 less than 4? And myself answers yes. And therefore, I believe I've done this properly. Now, it's not foolproof, because if you have your slope going the wrong way, or you end up with a minor error, but it's a pretty good way to check to see what you have going on. Let's try another one. So we said solve for y. I did not divide by a negative. I do not have to flip the sign. I plot my y-intercept of 2. I apply the slope of negative 2/5. Since the slope is negative, I think about it going this direction. So I know I'm going to go down 2, right 5, down 2, right 5, up 2, left 5, up 2, left 5. And I know I have a dotted because of this. And I know that my y's are greater than, where they get larger up there, smaller down there. So I'm going to shade this. This is the feasible region that is being shaded. All of the solutions that are in there, there's an infinite number of solutions that will satisfy this. Notice the origin does not fall in there. 0 plus 0 is 0 greater than 10. 0 is not greater than 10, and it did not satisfy my solution set, so I believe I have done this properly. Okay, x equals a number. Where is x4? 1, 2, 3, 4. 0, 4, or excuse me, 4, 0, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 4, 7, 4, 8, 4, 9, 4, 10, 4, 11, 4 negatives, and there we have it. It's a dotted line. It's a vertical line. Remember, x equals a number is a vertical line. And in this case, where do the x's get bigger? This is the x-axis. Bigger to the right, smaller to the left. I believe I'm over here. So these are special cases. And I believe the origin fails. Is 0 greater than 4? It does not. Let's try horizontal line now. Where is y negative 3? 0, negative 3, 1, negative 3, 2, negative 3, 3, negative 3, 4, negative 3, blah, 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 and I'm solid because I'm more equal to. And where are the y's smaller than negative 3, negative 4, negative 5, negative 6? It's down here. That's our Q. And again, the origin should fail. 0 is not less than negative 3. Next, we're going to take it up a notch. We're going to take it, we're going to take it to solving a system. So we're going to graph each inequality, and then we're going to shade the correct area. We're going to think about where it's going to overlap. The solution is where the shading overlaps. So if I have a system like this, I'll graph this top one, I'll make it red. Down 3, 1, 2, 3. Slope of 2, up to right 1, up to right 1, up to right 1, up to right 1, up to right 1. Looks like I'm solid. Solid as a rock. There we go. And I want to know where the y's are greater than. Y's are greater than up here. I believe I'll be in this section if you want to double check. So I just put a little arrow there to know I'm over here. I'll shade later. If you want to check the origin, put in a 0, put in a 0. Is 0 greater than negative 3? 0 is greater than negative 3, and I'm going to be shaded over here. So my red shading is going to be all of this. I'm just going to do it lightly, otherwise you can't see what you're doing on the next one. Next, I'm going to grab, let's grab this blue, sure. I'll do this one in blue. I go up to 2, 1, 2. See why I don't shade right away, otherwise you can't see. Slope of negative 1. Negative slopes go like this. Down 1, right 1, down 1, right 1, down 1, right 1. That's dotted. Dot, 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 dot. Let's call that the business. And then I go, where are my y's less than? This is greater than, this is less than, so I'll be below this. So I'm all of this, but what are we looking for? We're looking for the overlap. Let me grab a highlighter. Oh, that's zesty. Highlighter, let's see. So this region right here is the overlap of the red and the blue. Red and the blue. So these are the points that satisfy all of the given. So we're looking for where the two of them overlap, and those are all of the points that satisfy both equations. Isn't that fun? So again, the origin should work for both of them. Is 0 greater than negative 3? Yes. Is 0 less than 2? Yes. So I'm just plugging in 0 and 0 and then making them go. Here comes another one, just like the other one. Let's see what happens. I'm going to get the pen back. All right. And I'm going to graph the top one. I'll do that one in blue. 1, 2, 3. And then I'll apply a slope of positive 3. Positive slopes go up to the left. Or up to the right, excuse me. And it looks like something like this. And it appears as though I am solid. And where are the y's less than? They get less than down here. I believe I'm over this direction right now. And I'm just going to put a couple arrows there. I'll grab a different color marker. And let's go with, well, I think that's greater than in there. I assume so. And I got a 1 here. And I go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. And I'm going to be dotted. And I'm going to be above. Above is up here, so I'm this way. So if I look at where the blue one underneath the blue one, we're above the purple. And I'm going to grab a highlighter because that was kind of fun last time. And here we go. Here I go again on my own. There we go. There it is. Whoop. There it is. That's the section of graph that makes it go. Origin works for one, but again, we're looking for the ones that works for both. Actually, I think the origin fails both. 0 is less than negative 3. 0 is greater than 1. Origin fails both of them. I think I'm pretty good. The other thing you can do if you really want to check is you could actually grab a point that is in here. So I could grab this 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I could grab 7, 10, plug it in there. Is 10 less than 21 minus 3? Is 10 less than or equal to 18? Yep. And then is 10 greater than 7 plus 1 or 8? Yep. so it checks out. So if you grab one from the shaded region, then you're sure that you're good, because the origin doesn't always hold up on these ones. Okay, solve by graphing. Let's see here. Just by analyzing this, I would say, hey, heads up, heads up. You should be able to see this ahead of time here. We should be able to see, what are these? Whoa, what's going on? Come on. These are parallel. So you got to be careful now. I go up 1, apply a slope of -3/4. 1, 2, 3, 1, 2, 3, 4. And I have a solid line. And I'm shading above. So I still have to do this. I can't just say no solution or whatever. Then I go down to -2. And I have a slope of -3/4. 1, 2, 3, 1, 2, 3, 4. No surprise, they look very similar. Now, notice, you got to be careful because I'm going less than that one. So these ones are no solution, but that doesn't mean that all parallel lines will be no solution, because notice, I could have filled in between if the other one went down and up, which is exactly what happens right here. If I go up to 4 and apply a slope of 1/2, dot, 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 I'm shading below, but then I go up to 2, apply a slope of 1/2, dot, 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 but I'm shading above. So this one's below the taller one, the one that's above, and above the one that's below, and now I'm going to be in between, and that's unbounded. I'm in between the two of them. Okay, last thing for today, find the coordinates of the vertices made by the triangle. So what you need to do is you need to solve each of these individually. So I'll do this one in purple. So I'm going to have -y is greater than or equal to -2x minus 1. I moved the 2x over. Divide by a negative, I got to flip the sign. Don't forget that. That's going to be so important. So here's my first line, +1, slope of 2. 2, 2, 2, 2, 2, 2. And now we have solid, and I'm shading below that one, but it says I'm going to form a triangle, okay? So that should be a clue as to what this is going to look like. Next one, I'm going to move that x over there. Y is less than or equal to -x plus 4. 1, 2, 3, 4. -x, -x, -x. -x. And is this going to be kind of ugly there? I guess we'll have to see. Right through there. I thought this went through a better point, but I could be wrong. 2. Oh, I should have gone to 1. My purple line is wrong. Let me move my purple line. What a circus. Okay, I'm going to do the purple one again because I graphed it wrong. And maybe if you were following along at home, you're like, hey, you graphed it wrong. That's going to hit a nice point there. Okay, so I am currently below the purple and below the red. So I'm currently down here. So I'm assuming that this line, move that X over, slide that over. I got to get a different color. Let's do green. We haven't done green. 4y is greater than or equal to -x plus 4. Divide everything by 4. 1/4 x plus 1. Again, I'm at this 1. Good thing I redid that. Almost made my first mistake of the year. Down 1, right 1, 2, 3, 4. And I connect the dots. And I get above, right? I'm above. So I'm in between here. Oh, I should have used the highlighter. It would have been more fun. But they asked me for the vertices. Vertices are the corner points. So my vertices are 0, 1, and 1, 1, 2, 3, 1, 3, and 4, 0. And we're going to do more with those when we get to lesson 1.8. But for now, we're finding the vertices.